Now we will see the capacitance of three-phase cable. So in three-phase cable, what will happen? There is going to be three separate conductors, and each of them are going to have their own separate insulators, right? So if you take the entire cable to be like this, then you have the three cores somewhat like this. Okay, so these are, I have shown with insulator. So inside this you can take the core. This is the core. Okay, so this region, this entire region, it is the insulator for each of the conductors. Now what is going to happen? There is an insulator here, there is a conducting surface. So it is a capacitor, right? So there is going to be one capacitor in between these two conductors. Between these two conductors, another capacitor, similarly here. And again from the core to the metallic sheath. Here one capacitor, here one capacitor, and here one capacitor. Okay. So totally you will be left out with 6 capacitors like this. This is one capacitor. This is one capacitance. And the other 3 are from the core to the metallic sheath. Okay. So in between the conductors, whatever capacitors are there, that we will take as CC, core to core capacitance, and the other capacitors are from core to sheath. So we write as CS. CC is the core to core capacitance, and CS is the core to sheath capacitance. Now we will have to find out the capacitance per phase. So how do we do that? This is in delta connection, right? So if we convert it into star, then we will be able to get the per phase capacitance. Here at the center we will take the neutral point, okay, and we can take it to be at the ground potential. So in between this you have one capacitance. This is another capacitance, this is another capacitance. Now what will be the value of this capacitance? So whenever you convert from delta to star of equal reactances, what is going to happen? The reactance will be become 1 by third, right? Now here what is the reactance? 1 by omega C. So 1 by C equivalent, this will be equal to 1 by omega Cc into 1 by 3, 1 by third of this capacitor in each of the lines in delta configuration, right? So from here you are going to get C equivalent is equal to 3 times Cc. Okay, so here you can write 3 Cc, each of the capacitances. Now the metallic sheath will also be at ground potential. So what will be the potential from each conductor to the ground? So through this conductor there is one capacitor is going through like this, another capacitor like this. So you have two capacitors in parallel. Okay, so capacitance per phase is equal to 3 Cc and Cs in parallel. So capacitors in parallel will be added. So this is going to be 3 Cc plus Cs. So this is the effective capacitance per phase. So now the question is, how do we find the sheath and the core capacitances? How do we measure it practically, right? Here you have to make two different connections and measure the capacitances. So here this is the core to core capacitances, and here you have the core to sheath. Now what is going to happen? You have to connect all the cores together. Okay, that means basically you are short circuiting the cores. So here this is grounded, right? Now what will be the capacitance when measured across each core and the ground? So that we are going to measure, which is going to be Ca, capacitance between the three cores and the sheath when all three cores are shorted, right? This point is important. So now what is CA here? This will be, see, each of the conductors are together, so we can convert it into one single point, right? So if you take this as conductor 1, 2 and 3, so then we will take it as a single point where all the conductors are present, and one point we will take which is the ground potential. Okay. Now from conductor 1 to ground you have one capacitor, from conductor 2 to ground you have one capacitor, and finally from conductor 3 to ground, right? CS, CS and CS. Now this entire thing is CA. So how much will be CA? This is simply going to be 3 CS. Okay. So when you measure this capacitance, it can be measured separately. So CA will be known. From CA you can find CS. Okay. So once CA is measured, CS can be found as, or can be found from, if you take this as equation 1. So it can be found from equation 1. Okay. So what will be the expression? CS is equal to CA by 3. Now we have to find out the core to core capacitance. So here once again we will draw all the capacitances. So this time what is going to happen? We are going to connect two cores together, okay, and these two cores we are going to connect to the metallic sheath. Okay, so that means there will be another connection here. Okay, now you have to find out the capacitance between the other conductor which is not connected and the ground. Okay, so here this is going to be CB, we will represent as CB. So this is the capacitance between any two cores which are shorted with the sheath and the other core. So if you mark these conductors as 1, 2 and 3. So 2 and 3 are at ground level, 1 is at a separate level, right? So 2, 3 are at ground and 1 is separate. Okay, and the capacitance between the conductor 1 and ground, that will be, that you can draw here. So what will be that value? CS. Okay, and the other, these three capacitors, they will be shorted anyways. Here you have one capacitor from 1 to 2, one capacitor from 1 to 3. Okay, so both are connected to 2 and 3. So here you can draw two more capacitors, but this value is CC and this value is also CC. Okay, so this is CB. So what will be, say, the value of CB? This is going to be CS plus 2CC. Here CS we already know in terms of CA. Now CA and CB are the known values. We need to represent CC in terms of CA and CB, right? So CC is going to be 1 by 2 CB minus CS. Okay, so this is again equal to 1 by 2 CB minus CA by 3, right? CS is CA by 3. So this will be the core to core capacitance. Now we know CS and CC, so we can find out the effective capacitance. Okay, so effective capacitance, and remember this is per phase. So this was what? CS plus 3CC. So this is going to be CA by 3 plus 3 by 2 CB minus CA by 3. Okay, so if you simplify this, you are going to get 9 CB minus CA by 6. So this is the capacitance per phase of a 3-phase cable.